Well, thank you everybody for joining today. We've got some material prepared for an interesting discussion. And as Karen said, we will have a formal Q&A session at the end, but we do also have the opportunity for questions in line. So if something comes up, a point that I either didn't make clear or that you'd like to challenge or you'd like to ask about, feel free to go ahead and post that question. And I've assured Karen that she can't be rude and interrupting me because I love to be interrupted with good questions. So we'll try to keep that going and keep this session as interactive as possible. So my name is Mike Paquette. I work at Elastic, the company, and I'm responsible for leading product management for the Elastic SIEM solution. And I've been with Elastic about 4.5 years, and I've had the opportunity to work with the OmniSOC team really since its inception. And deploying different parts of the Elastic Stack componentry to make up the centralized log collection, security analytics, and ultimately the security information and event management capabilities that the OmniSOC offers and will offer. So what I wanted to do today was take a little retrospective, look at the history of how we've been able to collaborate together, but I wanted to bring everyone up to speed with kind of the current state of where the Elastic security solution is, how it's evolved, and even a little glimpse into where it's going in the future. So I prepared some material to lead us through that discussion today. So I know that some of you, I don't recognize all the names. Some of you I think are very familiar with the Elastic company and the solution. But if you'll bear with me for just a short moment, I'll take like a 5-minute dive from 30,000 feet down to ground level so we can get everyone on the same page, and then we'll dig into some details. So at Elastic, we think of the space into which we help users as falling into 3 solutions. A solution for searching called Enterprise Search, a search for traditional IT operations and metrics called Observability, and of course the area we're going to talk about today, which is the security solution. But all of these solutions are powered by a collection of software that has been developed by our company. We call it the Elastic Stack. It has components like Elasticsearch, Kibana, and Logstash, and Beats. And you may have become familiar with this technology stack as the ELK stack. We still respond favorably to the name ELK stack, but our official name for it is the Elastic Stack, and it consists of these components of software that are working together. So today, when we talk about the Elastic security solution, it is a set of curated user experiences and capabilities that are built upon the Elastic Stack. Now, just so you understand, because sometimes it can be confusing, the Elastic Stack and these solutions can be deployed anywhere. We offer a managed Elasticsearch service called Elastic Cloud, which allows our users to essentially just sign up and then start sending data into Elasticsearch deployments in our own cloud. We offer that cloud on the back end of, with the back end of major cloud service providers like AWS and Azure and GCP. And we also offer 2 solutions for deploying the Elastic Cloud that we call orchestrated solution. One is Elastic Cloud Enterprise. Despite the name, you can deploy this anywhere you want, on premises, on your location, in your private cloud, and your hybrid clouds. And then, of course, Elastic Cloud on Kubernetes, which provides the Kubernetes operator, Helm charts, and other associated componentry necessary to build out a containerized implementation of Elasticsearch. So that's what we as a company bring to the party today. Because we're talking about threat hunting and we're talking about OmniSOC, we're going to focus on the security solution. So Elastic Security, we've been providing solutions for security for over 5 years. But a couple years ago, almost 3 years ago, we decided to really double down. We found so many of our large users were putting together significantly sized centralized collection of security information together that we wanted to build a more curated experience for them. So in 2018, we began to build out a curated user experience for SIEM on top of the Elastic Stack. And even before that, we started building out a common schema, which is a common way to represent various types of security related data in a common format so that we could do pivoting and correlation implicit with search. But in October of 2019, we joined forces with a company called Endgame. Endgame was a leading developer of endpoint security solutions. And today, the Elastic security team, of which I am a member, consists of over 120 individuals who are focused on bringing to our users that curated security experience. And this team sits on top of the literally hundreds of other engineers that are building out the base componentry of the Elastic Stack through Elasticsearch and Kibana and Beats and agents and Logstash. So what we have right now is we have a tremendous development engine that is bringing forth new capabilities, new scale, new relevance, new performance, all together. And the OmniSOC team today, but anyone who's using this solution gets to take advantage of all those capabilities as we go forward. So the primary use cases that the Elastic Security solution addresses are ones you'd expect in a security analytics or SIEM solution. Those are monitoring compliance, threat prevention and detection through automated means, and then of course, hunting and incident response, where we have the human element to be able to identify activity associated with adversary threat activities. So I thought it was interesting to take a little look at the history, and this is kind of a mashup that I put together between the history of Elastic Security and OmniSOC. So Elastic predated OmniSOC. The company back after 2010 started putting together the fundamentals of Elasticsearch. The Logstash was the L in ELK, joined forces shortly thereafter, shortly after Kibana. So the ELK started back in the early 2010s, and Elasticsearch 1.0 was released back in 2012. Very shortly thereafter, we started seeing the use of the ELK stack for threat hunting capabilities. Think about what the threat hunting teams needed to do. They needed to pull massive amounts of data together and then use the power of search, ad hoc search, searching at the speed of thought across that data to produce results so that they could interactively look for things that were unusual, look for things of interest, perform their hunting, take their results, and then send them to incident response. So this was probably over 5 years ago that this was taking place. We launched Elastic Cloud. We introduced Beats to collect data from a variety of security sources. The place I joined Elastic was in September of 2016 when Elastic acquired a company called Prebuilt. Prebuilt is a company that developed the machine learning technology that's now part of the Elastic Stack machine learning. And back in 2018, when OmniSOC was formed, I was able to write a blog in March of 2018 that talked about the use of the Elastic technology as a significant component of the OmniSOC infrastructure. Shortly thereafter, and I know I've talked to the OmniSOC team many times that we wish that timing was a little bit different, we introduced Elastic Common Schema, and that was this normalized format that we had for defining fields and field sets and data types that allowed organizations to normalize their data so that hunting and pivoting and automated detection would become much more easy and repeatable. A couple other things. We had a couple of times, 2019 and 2020, we had Tom Davis act as a judge for our Elastic Search Awards and the Elastic Cares program, which was very, very interesting and a wonderful contribution to our community. But it wasn't until 2019 that we introduced the SIEM app. This was that curated experience that I described that was sitting on top of the Elastic Stack. It runs in Kibana. Kibana is the, if you will, the eyes and ears into the Elastic Stack for management and for data. And so we introduced the SIEM app. We had a couple of other acquisitions. We acquired a company called Perch that had a number of very highly skilled security practitioners. And then, of course, in 2019, the Endgame acquisition, where we added a massive amount of security expertise, individual with experience in threat research, both on offensive and defensive side, from commercial, United States intelligence and DoD community as well. And then one of the things that we brought into the solution from Endgame is a new searching technology called EQL, or Event Query Language. The folks at OmniSOC had been asking us when using the original Elastic solution, and even when we introduced the Elastic SIEM app, they're saying, isn't there a more powerful way that we can do correlations and sequences of events to help us both hunt and do automated detection on the adversary activity that may be present in our logs? And so the Event Query Language, which was introduced in 2020, gave us the capability, and this goes all the way down into Elasticsearch, where we can build out these event-based queries to help identify the different threat-related activities that might appear and by various combinations of correlation, including time-based sequencing. So today, where we are, we're getting together. It's the 3rd anniversary of OmniSOC. But what I'm coming to talk to you about today is this unified solution from Elastic, where we've taken the endpoint security technology from Endgame, and we've integrated those experiences into the same application that we had previously used to build out SIEM workflows. And so what we find ourselves with today is a set of unified workflows. And if you listen to the security industry a lot, you'll see a lot of just talk about extensible or expanded or even everything detection and response. You'll start to hear terms like XDR to describe this capability. And Elastic, interestingly, last year in 2020, one of the analyst firms, Forrester, had said Elastic is really out front by integrating these endpoint capabilities, endpoint protection capabilities, endpoint investigative workflows to add enterprise context and global context along with SIEM. And that continues to be the vision that drives us forward today. So it's been a fun road so far, and let's take a current stock of what is the current state of the Elastic Security solution, and let's focus on what capabilities for threat hunting are being added to the product as we go forward. I'm going to pause for just a moment to see if there's any questions or any comments so far.
I do not have any questions so far to share with you, but that may not be because questions weren't asked. It may be because I'm having some difficulties. So I'll let you know when I get that fixed.
Okay, thank you, Karen. No worries at all. We still have time reserved at the end for the formal Q&A session, which we'll take advantage of. So Elastic has become a very popular choice for security analytics use cases, including SIEM, and as you can see here, and of course, OmniSOC is in fine company regarding those who chose Elastic for their security solutions. If you think about, as I talked about before, the three major use cases, monitoring compliance is all about gaining visibility to security data. This is a foundation for good threat hunting, the ability to ingest, index, and make available for visualization all the data that may be relevant, from all of its relevant sources. From threat prevention and detection, we've got a couple things. It's about automated detection to complement threat hunting, and it's about triage and investigation of what is detected in a very, very efficient way. Another piece of really powerful technology that Elastic acquired through the joining of forces with Endgame is a technology that you see shown here in the diagram, which is the ability to automatically create process ancestry trees and display them in a way that is super, super easy for analysts to understand. So at any time, if you're hunting or you're doing alert triage takes you into the execution of processes on a host, then not only will you have all the data available, but you have nice visualizations that let you understand this exact progression or genealogy of the process execution trees. And today's topic, we're going to talk a little bit more about, which is the hunting and incident response. I'm going to show you in just a moment the data architecture of the Elastic Security solution. And the thing I'm going to highlight is that we've provided a investigative workspace that is central to both the threat hunting workflows and the automated detection workflows. And we're going to see that that's really what we're going to talk about for the most of today. So our vision, it sounds kind of very high-minded, but it is to protect the world's data from attack. As I mentioned, many of the security researchers that we have at Elastic are absolutely driven by this mission every day that they get up and they come to work. We have a philosophy to bring openness to security. We do not believe in security by obscurity. So we have done, for example, in 2020, we created an open source GitHub repository that contains all the development activities for all the pre-built detection rules that are being developed as part of Elastic Security. So this isn't just a set of things we throw out there. This is where our developers live. This is where they develop ongoing protections, where they curate, update, modify, where we accept contributions from our community members, and where community members can make requests for new things. But putting this out in the open is consistent with our philosophy of this bringing openness to security. Because we are Elastic and we built our security solution on top of the Elastic stack, our goal is to help eliminate any limitations that have been imposed by previous solutions based on scale, speed, and relevance of data. And as I talked about already, what we're trying to do is provide this unified security platform that's based on both the Elastic and the expertise that came with the joining of forces with Endgame. So I'd like to talk about the way that we address security analytics in SIEM using a pyramid. And I start from the bottom up, which is a way that Elastic, bottom up to us means that everything we do in developing software is targeted at helping our users accomplish their own mission. And so when we talk about our vision for SIEM, we start with, as I've talked about, the fast scalable search engine that is the Elastic Stack based on Elasticsearch. And it's based on the open schema that we call Elastic Common Schema. I know some of the OmniSOC team has been very familiar, in fact, working with us closely over the past years as we develop the Elastic Common Schema, and the Common Schema continues to grow. This is developed in the open. It is open source. It is community sourced. It is not a proprietary structure. And very interestingly, we're finding more and more cases where folks are using Elastic Common Schema even outside of Elasticsearch, which is very interesting because we designed it to be optimized for the use within Elasticsearch. With this platform underneath our feet, we then talk about detection analytics. And this is where threat hunting and automated detection use cases come in. Our vision for detection within the Elastic Security platform is to build a unified rule management and detection experience that draws from multiple underlying analytic capabilities of the Elastic Stack itself. So today, when last time I believe I gave an update about a year ago, we had 2 different detection analytics. We now have 5. So we've had a continuous expansion in the number of underlying analytics that can be deployed as part of the automated detection rules, starting with queries, aggregations, machine learning anomaly detection jobs, the new Elastic event query language for sequence-based correlations. And most recently, we've introduced an indicator match rule capability where you can specify a second set of indices that contain your indicators, perhaps threat indicators, and then you have a single rule that reads from one index to gather the relevant indicators and then looks across other indices, either in near real time or retrospectively, to find any matches that your log data may have had against those. We plan to continue by adding more and more rule types, but that unified rule experience is going to make the detection engineer and the investigating analysts be so familiar with this concept that independent of the underlying analytic, they're going to go through the same hunting workflows and the same alert triage and investigation workflows. So the platform, and with detection under our belts, we now talk about it's down to rich experiences and easy workflows. Over 85% of our users today are using human-in-the-loop workflows, but we are seeing more and more requests for automation. So as we continue to design the Elastic Security solution, we're keeping both of those in mind, optimizing for maintaining analyst velocity and analyst success while using the product, but putting hooks in so that we can increase the amount of automation over time. Let's see, 1 year ago, if you had asked me on the Elastic Security solution, how much out-of-the-box protections do we provide? I would have said, not much, but well, we're going to be delivering those soon. Our vision hasn't changed, but our execution has been massive. We've gone from 0 to over 450 curated detection rules that are now available to run within the Elastic SIEM solution. And as I said before, these aren't just thrown out there. These are curated by a set of intelligence and research engineers that are looking at these all the time, tweaking the logic of the detection, making sure that the metadata is up to date, and we're providing these to our users as part of our pre-built protections. These are available in the open source GitHub repo. The Elastic Security solution has been built to not only take these rules from Elastic, but also to be able to import rules from other people within the community, and basically to let you to create, export, import, share rules, and use from Elastic. And lastly, but not least, is our vision for our community. It's the users of the Elastic solution, it's our customers, partners, it's open projects and distributions that are using the Elastic Stack that kind of make this whole thing possible. So this has been the vision that has driven us for almost 3 years now, since August of 2018, so about 2.5 years. And we continue to make progress towards that vision with the Elastic Security solution. Now, at Elastic, one thing that our company is known for is for developing software rapidly and frequently. So we have releases that we call minor releases of our software stack approximately every 2 months. And that's it's a curse and a blessing, right? The curse is you have to upgrade a lot, but the blessing is if you don't like something, just wait till the next release because we'll probably make it better. And the pace of innovation has been rapid. Since the Elastic Security solution was introduced as the SIEM app, we've made just absolutely rapid progress with these hundreds of expert-based detections, highly operationalized machine learning anomaly detection, investigative workspaces that are proving to be highly efficient for analysts to get their work done. And of course, it's all architected for scale. So let's talk about the most, I'm going to pause for a moment and see if there's any questions, but let's get into some details about the most recent of those minor releases, which is 7.11. Karen, anything come up yet that I should be aware of?
No, not yet. And I am just about fixed.
Okay, well, very good. All right, well, one way to describe to you and to talk more specifically around the threat hunting capabilities is to describe the overall architecture of the Elastic Security solution. This is built in data flow fashion. It reads from left to right on your screen. It's not dissimilar to what you might see at a high level from many security analytics capabilities, but I'd like to describe a few of the high points of it. If I can even use animated pointers. So it starts with data on the left-hand side. And of course, any security analytics SIEM solution is going to be most effective when it can import data from many sources. So of course, we have that through our Beats or Elastic Agent or Logstash input. As data comes into the Elastic Security solution, it is stored in Elasticsearch indices. And the Elasticsearch indices are basically, extremely flexible in terms of tuning the performance for ingest rate, query rate, and the storage that you need for basically how much data retention you need to keep. But there's going to be two workflows we talk through today. The one that goes straight across the middle is the automated detection workflows. This is where the detection rules that I talked about are operating. They operate in the detection engine. So the rules operate in the engine. The engine draws from those underlying analytics that I talked about, the 5 different types of rules. And one thing we did with the Elastic Security solution that's somewhat different to traditional SIEM is that we've deconstructed the alert from the notification that goes with the alert. So in other words, every time a detection rule runs and it triggers, its conditions are triggered, it writes the results of the detection into another Elasticsearch index, where you get all the rights, honors, and privileges associated with having data in an index, which means you can visualize it, analyze it, and process it to your heart's content. We made optional the notification, where traditional SIEMs kind of lump together the notification with the fact that something was detected. We made those optional. And the reason is because with these detections available in an Elasticsearch index, our detection engine is bidirectional in the sense that it can operate not only on new data that's been ingested into the SIEM, but it can also operate on previous detections, allowing for a hierarchical type of automated detections that allow you to even think about building up different classes of detections. You could have building block detections that you never want to have notifications about, but you do want to use them to build higher fidelity subsequent detections on. And this all works as part of the detection engine with the Elastic Security solution. Now, let's get to the threat hunting parts. When people are using the Elastic automated detection workflows, the alerting workflows, they are using our timeline investigative workspace to perform triage and investigation on the alerts that have been written into those indices, right? And we've got some optimized paths. If you really know what's going on, you can actually bypass that. But we're not going to bypass it today because this is the area where the commonality comes between the alert investigation and the second set of paths, which is on the lower part of this diagram, which are the threat hunting workflows. This is where organizations that have deployed the Elastic Stack get to use all the tools. We provide some nice hunting workspaces and host and network visualizations, but they can also use capabilities like the thresholds and aggregations that are available through Elasticsearch. They can use machine learning based anomaly detection jobs. We've done a number of presentations about hypothesis-based threat hunting using machine learning. You can use the underlying queries within Elasticsearch. You get all these capabilities of analytics to assist in your hunting activities. But when you find something of interest through hunting, you can simply drag that information into the same timeline that you're familiar with from doing automated detections. You can expand and narrow your search. You can read events in a rendered format that is very analyst friendly. And of course, in either case, if you decide that what you've investigated is worthy of escalation, you can go ahead and escalate it by creating a case right within the Elastic Security app. And if you have third-party case and ticket management systems, we've given you the ability to both push and update cases to your third-party systems right within the security app. Of course, not everything needs to be escalated, and sometimes you find things through hunting or through alert triage that need to have exceptions made. So we've got a built-in exception path that allows you to create exceptions for rules so that in the future, the rules won't be generating the detections that you'll have to investigate. As part of our unified security solution, we've extended that exception workspace to be able to send exceptions that are relevant to endpoint protection all the way down to the endpoint. So the endpoint never even has a positive detection of something if it's an exception condition. So this workflow is what has been driving the Elastic Security capabilities, and the threat hunting workflow is is one that we got started with. It's near and dear to our users' hearts, but what we are finding is that a lot of the detection engine capabilities are also useful in threat hunting environments. So in the 7-Eleven, so remember, about approximately every 2 months, some of you may not be familiar with these capabilities, but the most recent one, which was last month that we introduced 7.11, we had a number of new features. And while I'm happy to go through these in detail, I'm probably just going to give these a scan through the rest of this discussion so we can talk about some of the forward-looking stuff as well. So they fall into 5 buckets. One are improvements in the detections. These are the automated detections that we're providing. The second is what we actually provide. So as I mentioned, over 461 rules that provide tremendous coverage around the space of the MITRE ATT&CK framework across different data sources from hosts, from network, and from cloud infrastructure and application providers. We'll talk about some enhancements to workflow that help with investigation and collaboration, including alert triage and hunting. Some new data source integrations that make it easier to get data in from the various data sources that are relevant to our users' environments. And then if we can even talk a little bit about what are the latest in terms of endpoint security capabilities. So let's start first with the detections. What we did now is we've added a bunch of new rules for cloud applications in Windows environments, detecting attacks and both attacks and hygiene issues with cloud applications like Google Workspace, Microsoft 365, and these complement a bunch of the pre-built detections that we already have for infrastructure as a service technologies like AWS, Azure, and Google Cloud. Anomaly detection. The Elastic Stack has an extremely capable and perhaps the most highly operationalized machine learning of any security solution that we're aware of. And the machine learning basic entity of work is called a job. And what we're doing is we're shipping now over between 40 and 50 machine learning jobs are being provided by the Elastic default distribution as pre-built machine learning jobs. These, as I mentioned earlier, are nicely integrated into the same rule management experience. And one of the things that we did in 7-Eleven is we took a number of those jobs that were focused on Windows and Linux hosts. And what we've done is we've adjusted the job so that it works on data coming from multiple sources. Guess what? Using Elastic Common Schema. So we're adopting more and more Elastic Common Schema into the machine learning jobs so that regardless of whether the data comes from for example, a WinLog beat on a system that's running Sysmon, or perhaps an Elastic agent that has a Windows integration, or some other source that's been integrated. If those data sources are using Elastic Common Schema, then these machine learning jobs will perform the automatic modeling and detection of anomalies based on that data. So it's really, really just providing the pre-built capabilities to a more expansive set of input data for our users. There was a number of detections that we made, particularly in response to the sunburst attacks. but we also did some amazing research in 7.10 and 7.11, where for the first time we combined trained supervised machine learning with unsupervised machine learning based anomaly detection to detect attacks associated with DNS domain generation algorithm activity. And it turns out those also were very effective at detecting the known communications that were implemented through the Sunburst SolarWinds attacks. And yeah, here's a little bit more of the detail here as well. If you are interested in that topic, we did write a very, very detailed blog about how the combination, this powerful combination of unsupervised machine learning along with trained machine learning models was able to provide extremely effective and high efficacy detection against DNS activity associated with DGA. So talk about the pace at which we're innovating. This is the number of new pre-built rules that we introduced in 7.11. A lot of them taking advantage of that new elastic event query language, which allows for much more complex joined sequence-based correlations. In terms of how that worked out, over 100 of these new rules were based on the new event query language, which is proving to be extremely powerful. More breakdowns about the rules. I'll skip over that. So the second thing we did was made enhancements to the way that the detections and the alerting take place. And this is where the threat hunting capabilities can come in as well. If you do follow MITRE ATT&CK, you'll know that over the past year, they've begun to introduce MITRE ATT&CK sub-techniques to complement the tactics and techniques that exist today. And so we were staying ahead of the game, having classification of our detection rules that include the MITRE ATT&CK sub-techniques. And indeed, if you're doing your own rule creation within the Elastic Security solution, you can add tactics, techniques, and sub-techniques as well. So this is really important to a number of our users to be able to have a commonly accepted framework against which they can measure not only the rules that they have, but the rules that are deployed so that they can know the kind of coverage that they're actually getting. I talked earlier about the deconstruction of the alert detection from the alert notification. And that's not to say that notification isn't important. So what we've done is we added a number of new action types that are associated with notification once the rules conditions are triggered. So in addition to what we've had for a while, which is email, PagerDuty, Slack, and webhook, we also have direct actions that can reach out to IBM Resilient, Jira, and ServiceNow. Again, a lot of our users, if they're not finding what they're looking for here, they're using the webhook to be able to have actions that are integrated with other systems they might have, like home-built systems that they put together to manage this. The exception workflows, we've now made those universally accessible across almost all of our rule types. And here's one that's really, really exciting. In the 7.11 release, the Elasticsearch introduced a new data tier called the cold tier. And the cold tier makes use of a construct called the searchable snapshot. So if you are familiar at all with Elasticsearch, you'll know that the storage of data is the mechanism by which high-speed data indexing takes place. It's also the mechanism through which high volumes of searches are addressed and serviced. And what we find is that there's those high performance ingest and indexing and searching operations require a lot of data. And so we find that for a lot of our users, they have data that isn't in such high demand for searches, and it's no longer being actively added to. And so what we've done is we've created a new tier of data called the cold tier, which keeps a single replica of the data inside Elasticsearch indices. But the replicas, which are normally used for parallel searching, the replicas are stored off cluster in a highly cost-effective object store. Think of something like an Amazon AWS S3 bucket. And because of this searchable snapshot, when you do have a query that's looking back over that old data that might be stored in cold tiers, it will automatically know how to pull that data directly from the searchable snapshots. In other words, there's no action that your team has to take to rehydrate that data to make it searchable. This is all done completely transparently to the user. And the reason this is so exciting is because In the future, and again, I'll give you a disclaimer in a moment, the future technology that I talk about today is not a commitment by Elastic, but it's something that is actively being developed. And so we ask you to keep that in mind. But the new tier will be a frozen tier, which offers that same capability to directly search data that is stored in cost-effective object stores. And this, from our security users' point of view, is going to be extremely exciting, giving them the ability to transparently, with no restoration from backup, to issue searches that will be spanning extremely long periods of time, a year or a couple of years. Yes, are they going to take a little bit longer because they're in this storage? Yes, of course. But compared to what competitive solutions need to do today to to look back across massive amounts of data, this is going to be kind of a revolutionary change. So we're very excited to introduce the beginning of searchable snapshot support in 7.11. I've always wanted to have a slide that had 5 S words at the top of it, but that's how I got started with this one. And it's supported for most data that's used by the security solution today, with a couple exceptions. Those indicator match rules that I described earlier, those, because of the dual query nature of those are not yet supported in cold tier, but otherwise all the data that you're ingesting can work in hot tier, warm tier, and cold tier data. And I'll skip over this for a second. So there've been a number of enhancements to the usability and accessibility, especially for analyst alert triage and well as threat hunting. We've got a new alert details flyout view. So if you are looking and investigating alerts that have been generated by the detection rules, and instead of scrolling through them in detail, we've got a nice alert details panel that pops up. This is, again, to create the preservation of velocity of the tier 1 and tier 2 analysts that are looking at the data. We've got a lot more efficient alert management, specifically with regards to Elastic cases. So you can now synchronize alert state. If you've added an alert to a case, you close the case, the alerts will automatically receive a closed state, so that you'll be able to very efficiently move the way through all of your alerts. The timeline, as I mentioned, which is that very flexible investigative workspace for both threat hunting and alert triage and investigation, has been really improved from a usability point of view. We've got full screen views now that expand the viewable area. We've got multi-column sorting that allows the analyst have pre-built timeline templates that, depending on what they're investigating, will have the appropriate columns and the appropriate sort order and the appropriate filters in place to really let the analyst hit the ground running when they're performing these investigations. And we've made the navigation throughout this workspace accessible to all. Keyboard navigation, hotkeys, screen reader support, all being added in. Previously, the drag and drop functionality was very powerful, but wasn't very accessible. And so we made significant improvements in that in 7.11. This event analyzer has become even more powerful. And this tool by itself, there's an excellent blog, which I'll be glad to send a pointer to, that was talked about using the Elastic Security as a malware analysis sandbox. And this analyst that went ahead and did that set this up in very short order, but found this capability to be able to look at process tree, process history, execution to be absolutely invaluable in assessing whether or not a particular sample was basically performing malware-like activities. So an excellent blog. If you're interested in that topic, you can go ahead and have a look at that. In terms of data sources, the biggest evolution change that we're making at Elastic is we're moving to a consolidated Elastic agent. Whereas in the past, depending on what kind of data you wanted to pull from Elastic, if you were using Elastic beats, you may have had file beat, metric beat, winlog beat, heartbeat, endpoint, APM agent for all these different types of data sources. And our vision going forward is there's going to be a single agent that runs on every host. And based on the integrations you configure through policy, you get to choose what type of data that agent is going to be pulling and collecting for you for your enterprise context or for your global context enrichment. Oh, and one of those integrations happens to be the Elastic Endpoint Security. That's the malware protection with additional protections being added to it as we go forward. We've added support for a number of common data sets, Google Santa, Google Workspace, IP tables, Linux, Audit-D. These are all set of integrations for Elastic Agent, where previously they were parts of FileBeat. We're now making them available regardless of which approach you choose to use for your data ingestion, which is really nice. New data sources like database audit logs. We've got MySQL and Oracle database, and vulnerability and audit logs from Sneak, a vendor that's we've been seeing pop up in a lot of our users in recent history. Elastic Common Schema. All of our integrations were updated to Elastic Common Schema 1.7. We tend to have updates to Elastic Common Schema with every release of the Elastic Stack, so we're constantly making sure that those keep up to date. So there's a lot of new capabilities that have been added in to Elasticsearch 1.7. Elastic Common Schema 1.7. And then lastly, the malware prevention. We've added additional self-protection capabilities when the Elastic Endpoint Security for Agent runs on Windows. Same thing for Mac OS. And this is on by default. So to help protect your Elastic Endpoint Agent-based security from being tampered with. The Elastic Endpoint Security solution is now a registered antivirus solution with Windows. So if you choose to, within Windows, you can designate the Elastic Endpoint Security as your antivirus provider. We've got a number of new customizable user notifications. So that on the system on which the agent is running, you can get notifications for your users as you see fit by policy of your IT operations or endpoint management systems. And then finally, we've beefed up the trusted application details. Trusted applications are part of life when dealing with endpoint security. And so we've made a number of new capabilities, including the ability to specify by signer available. And then overall, we're making great steps in simplifying the management of the Elastic Endpoint Security integration with Elastic Agent. So we had a number of updates in 7.11 to make that process easier and more robust. So Karen, I've been talking for a long time, and that's kind of wraps up my current state session. And I'd like to pause and see if there's any questions so far. And if not, we'll go to the future.
Thanks, Mike. No, we don't have any questions thus far.
All right. Well, very good. Well, then let's get to the last portion of today's presentation, which is the future vision. The vision that Elastic Security holds is very consistent with what you saw me present at the beginning of the presentation regarding the vision for security and the vision for SIEM. But in terms of product capabilities, I am required to share with you the safe harbor statement because the pieces I'm going to talk about now are forward-looking. Elastic does intend to develop them, but we don't make any commitment that we will. And we ask that any interactions you have with Elastic are based on what our product has today, not what I talk about in this section. Our roadmap is generally thought of in three pieces. There's things we're researching. These are ideas that we're exploring, and some of these will be moved to the next stage. The designing is the next stage where we take research that made it into the design phase, and many of these will move to the third stage, which is developing, where we take designs, and most of these will be live soon. And we generally think within the security solution of our research, our designs, and our development taking place over these half a dozen or so use cases. The SIEM use case, which I talk about a lot, security analytics, which is the more essential performing of visualization analytics on security log data, endpoint security that I just talked about, threat hunting, the discipline that we focused on for a large part of today, cloud security, and security operations. So in terms of things we're researching, one area that we've been adding capabilities to the Elastic Security solution is with threat intelligence integration. And so for SIEM and security analytics, we introduced this indicator match rule type in 7.10, and we are working on how to really simplify this threat intelligence ingestion. How do we get data from multiple feeds, open source and commercial feeds you may pay for, get them into native Elasticsearch indices, and then use the indicator match rules to find for you both near real time and retrospective or historical matches of artifacts within your logs matching up against these indicators. On the endpoint side, integrating host response. This is technology that the Endgame team had a lot of success with, which was the ability to isolate hosts that have triggered some type of malware detection, for example. And another expansion is in-memory protection. A lot of the anti-malware stuff right now is working on process executions and things that are opening files and accessing files. But the in-memory protection is another area that we're looking to add into endpoint security. On the design side, the host response actions I just talked about will be introduced. We plan to introduce Linux malware protection as well, in addition to the Windows and Mac OS. And we're also integrating OS query management. This is not required to use OS query, but we're finding amongst our users, there's lots of them that have deployed OS query to help them usually monitor, but sometimes monitor and control capabilities within their fleet of endpoints. And so we'll be embracing OS query, introducing that into the agent infrastructure and allowing you to manage and operate an OS query based fleet within the Elastic Stack itself. On the development side, we're expanding our malware protection to include explicit ransomware behavioral protection for Windows in upcoming release. In terms of third-party cases, we'll be introducing, and we already have connectivity to ServiceNow ITSM, but we'll be asking it for the security incident response from ServiceNow, or SecOps as it's sometimes called. The threat intelligence module will be embodying the integration with the threat intelligence sources, both open source and commercial, Anomaly and a couple others, the first ones that we're working with already on the commercial integrations. And then, of course, we'll continue to expand the set of data sources from which we can integrate data into the Elastic Stack. I talked about the searchable snapshots. It is the plan of Elastic to introduce the frozen tier data, which we think will really allow for types of retention periods for data that are impractical today. Keeping data for extremely long periods of time on extremely cost-effective storage and having it accessible to search, to your analysts, to your threat hunters, without any explicit action like remounting or rehydrating the data. So that's the promise. We're very excited about that. We'll be working to integrate the availability to use frozen tier data in most aspects of the Elastic Security solution once the frozen tier data becomes available. Here's one you haven't heard us talk about much at Elastic. Elastic typically has enjoyed the performance and scalability benefits of performing schema on write. It takes extra work, extra power to ingest the data into Elasticsearch, but because everything is indexed, it means your searches, especially searches on things you didn't know you were going to look for, is much, much faster. And this has always been an advantage. This is why security analytics became popular on Elastic 5 years ago. But one drawback that it has is you kind of have to know what the data looks like before you ingest it. When you have unformatted or slightly or totally non-formatted data that's being pulled in, there wasn't an easy way to perform efficient searches on that. So what we're doing at Elastic is we're embracing the concept of schema on read. This gives you flexibility, the ability to control the cost of data that you're ingesting. And most importantly, it gives analysts the capability to construct new fields at query time, even though those fields may not have already been indexed in Elastic. So the idea here is these capabilities will be available throughout the Elastic Stack. They're part of Elasticsearch, they're part of Kibana. We'll be embracing these in the security solution as well, so that when you do have a query, let's say you want to know something that isn't in an indexed field, but you know it is present in the document, you can write an extraction that is part of the query itself that defines this runtime field that allows you to then subsequently use that field in all of your analysis, whether that be visualizations, aggregations, or any subsequent work that you do on the data. So this is a big change. There are capabilities that have shown up in 7.11. We expect more of that to show up over the upcoming releases. And we think this is going to really round out the capabilities of the Elastic Stack in general and Elastic Security to provide the speed, performance, and scalability of index data, along with the query time flexibility when you don't have the ability to have the index fields. So that is a brief, but hopefully fairly comprehensive update on the current state of how the Elastic Stack provides capabilities for current and future threat hunting and automated threat detection. And I would be more than happy to entertain some questions or accept some feedback or any comments or any type of interaction at all.
Mike, there was a question along the way asking what KQL stood for, and it may have been answered, but in case not everybody could see the answer, would you want to define KQL?
Yes, certainly. I used a variety of terms that may be a little bit too much on the Elastic language. Let me see if I can pull up a diagram and I'll show you that real quick. So when earlier I talked about the underlying analytics that make up the Elastic detection engine, I said there's a number of those, and I had a bunch of QLs down here, right? So this first KQL stands for Kibana Query Language. It is a default autocomplete type ahead language within Kibana that's very simple, allows logical operators in the specification of fields and values. And it is sort of the default language available when you're using Kibana, which is the eyes and ears into the Elastic Stack. So within the detection engine or within almost any page within the Elastic Security app, you're able to use KQL-based queries and filters to identify the data that you're looking for. So it's Kibana Query Language. I know there are other vendors. Microsoft has a KQL. This is not Microsoft KQL. This is Elastic Kibana Query Language. In contrast to the EQL, which is the event query language, this is the language that allows you to specify complex sequence-based correlations, whereas KQL would be more traditional, looking for single documents based on logical matches. This field is one of these values, and this field is one of these values, or this field is this value. That would be typical KQL, or EQL could be find me all process events that take place where the process name looks like this, and then next find me any file events for which the parent process is the same process name that I looked at previously. Like really complex things can be accomplished with EQL. So we call that more of our advanced correlation query language.
Thank you. That's all of the questions I have, but I also have someone who commented that they felt this was a really useful session and full of really important information, so much so they wanted to go back and watch it again. So they were asking if it was recorded, and it was. So we will be sending out a URL through email to get to the recordings. It may take 10 days to get that out there, but also your slides will also be linked to that recording.
Oh, yes, indeed. I will make the slides available.
Oh, here are more questions that just came in. Wow, just wow. Thank you. Really nice slides and visualizations too, like that operational workflows slide. Are any of the ML and anomaly detection capabilities available in the free tier distribution?
Excellent question. I did not focus on free tier versus paid. So the question is, I talked about these machine learning anomaly detection capabilities. I talked about a number of machine learning jobs, 40 to 50 of those. And I talked about rules, detection rules that govern the operation and execution of those jobs. That is a paid feature. So the machine learning jobs and the machine learning engine are not available in the free version of the Elastic Security solution. Those can be obtained through a trial. If you're using it on-prem, you can just simply enable a trial. You'll have the bits there. You'll be able to try it out. If you do a trial on Elastic Cloud, you'll be able to get those as well. But those are indeed paid features. So thank you for bringing that up, and that's a good question.
Thank you, Mike, for that great presentation. That's all the time we have for today. Thanks to everyone who attended. And if you'd like to continue the discussion, we invite you to do so using the Whova app.
Thank you all very much. I appreciate the participation, and glad to say happy anniversary.